Okay, so we're going to go over 2013 AP Calculus BC free response question number 6. It has 3 parts, A, B, and C. And so here are some of the things we're going to do in this video. We're going to, 1, go through each part of the problem and solve one by one for each part. Have useful information and explanation for each of these parts. Look at College Board's grading point distribution for each part. And look at some tips and tricks for the AP test. So let's get started.
6 says a function f has derivatives of all orders at x equals 0. Let Pn of x denote that the nth degree Taylor polynomial for f about x equals 0. A says that it is known that f of 0 is equal to -4 and that p1 of 1/2 is equal to -3. We must show that f prime of 0 is equal to 2. So first thing we want to do is know what p1 of 1/2 is equal to. We have a Taylor series about x equals 0, so this is technically a Maclaurin series, but we want to find what p1 of 1/2 is in a Taylor polynomial definition. So what does this one denote? Well, it denotes that we must have the Taylor polynomial go up to the first derivative. p1 of 1/2 is equal to, by definition, f of 0, since we're modeling the function f with this Taylor polynomial, divided by 0 factorial, plus f prime of 0 times x, which in this case we're plugging in 1/2 for x, because it's Pn of x, so x is 1/2, minus a, which is what the Taylor polynomial will be centered around, and we know it's centered around 0, divided by 1 factorial. We know that this whole function, by what it says in letter A, is equal to -3. So all we need to do is plug in what we know and then solve to try to find what f prime of 0 is equal to prove that it's equal to 2. So we see that f of 0 is equal to -4, and we divide that by 0 prime, which is just 1. Then we add f prime of 0, which we don't know what it is, multiply it by 1/2, because that's what 1/2 minus 0 is equal to, and then divide it by 1, and this is equal to -3. We put the -4 and we bring it to the other side and then multiply by 2, and it's easy to see that f prime of 0 is equal to 2, because 1 times 2. And this is just our answer.
Okay, so let's see how the AP actually scored this one. We see that the AP scored it such that if you have this equation with all the stuff that you need to plug in, that's 1 point, and the answer itself is just 1 point. So we got both of those points right here.
Let's move on to part B. Part B says that it is known that f double prime of 0 is equal to -2/3, and f triple prime of 0 is equal to 1/3. We must find p3 of x. So again, p3 of x has that 3. That means that we're just going to go up to the third derivative. So by definition, this is equal to f of 0, just like we did last time, plus f prime of 0 times x minus a over 1 factorial plus f double prime of 0 times x minus a squared over 2 factorial plus f triple prime of 0 times x minus a cubed over 3 factorial. So one tip just for this type of problem on the AP test is they give you a bunch of values. We're just going to plug and chug until we get a Taylor polynomial just with x's, no a's, no f primes of anything, just x's, and have that Taylor polynomial. All we need to do is plug and chug. It's really simple. So this is just equal to, like we did last time, -4, f of 0 is -4, 0 factorial by definition is just 1, plus 2 times x minus 0, again 1, f prime of 0 is equal to 2, plus -2/3 x minus 0 squared over 2 factorials, 2 and f double prime is equal to -2/3, plus f triple prime, which is 1/3, times x minus 0 cubed over 3 factorial, which is 6. And then finally, we're just going to get the answer after simplifying these things, and we get -4 plus 2x minus 1/3 x squared plus 1/18 x cubed. And this is actually going to be our answer.
Okay, let's see how the AP scored it. So they scored it such that the first two terms, the points were only in the answer. The first two terms were 1 point, the third term was 1 point, and the fourth term was also 1 point. The reason why they did this, or I suspect that they did it this way, is that the first 2 points, you get the point no matter if you put these factorials on the bottom of the fractions. The second 2 points, you must know that these factorials on the bottoms, and it will change the answer of these last two. So there's 1 point for each of those, and 1 point for these first 2 terms, because it doesn't matter if the factorials on the bottom, because they all equal 1. Okay, let's start with part C. Part C says that the function h has the first derivative given by h prime of x is equal to f of 2 of x. It is known that h of 0 is equal to 7. We must find the third degree Taylor polynomial for h about x equals 0. So just looking at it, we know this is going to be a creative problem. What I like to do is define the new third degree Taylor polynomial for h as a different function than the Pn of x, which denotes the Taylor polynomial for the third degree of f. So I'm going to say that this third degree Taylor polynomial is going to be equal to g3 of x. That 3 is denoting that third degree Taylor polynomial again. So by definition, this g3 of x is going to be equal to similar to part B, plug in all these numbers to find that Taylor polynomial for the third degree of h. The problem is we only have numbers, as you see here, of f of x. So we're going to have to find the derivatives of f of x using this equation, h prime of x is equal to f of 2 of x. So what we're going to have to do is plug in all these numbers, so just substitute these things in. So what we get is h of 0 we know is 7. 7 divided by 0 factorial by definition is still 7. So we're going to get 7 plus f of 2 times 0, since it's the definition of h prime of x, which is right here, multiplied by x minus a, which is, we're still centered around 0, so it's still going to be 0. And that's all going to be divided by 1. And then we're going to get plus 2 times f prime of 2 times 0 times x minus a squared, or 0 squared, because a is 0, divided by 2. So why did I put this 2 in front of the f prime of 2 times 0? Well, if you see here, when we take the second derivative of h of x, we're going to have to take the derivative of f of 2x, and there's a chain rule there. We have this residual 2 that must be put on the outside. So we have that 2 out there. And then we're going to add the last part, which is 4. Since we don't have the chain rule again, we need to multiply it by 2 again. Have the f double prime of 2 times 0 times x minus a here, cubed, this a is 0, divided by 6. We're going to actually move on to the next paper because we don't have enough room on the screen. So we have this equation, and we're just going to plug in these new things. So as you see here, these just cancel out to 0. These are just 0. These are just 0. And we know these terms because they're right here. So we're going to just plug in those terms. Just trust me on this. 7 plus 4, since we have this negative 4 right here, it's going to be plus negative 4x plus 2x squared. So since when the 2's that we have right here are just going to cancel out, we're going to just be left with this 2 right here. Be minus 4/9 x cubed, which is just basically multiplying this by 1/3, because that's what f double prime of 0 is equal to. And this is just going to be our answer. So how does the AP actually grade this? Well, the point distribution for this question is 1 point for, here, let me bring in this other paper right into here, is the application putting this f prime in for h of x. That's just 1 point. It's just the application of that. The next point comes from just getting the entire answer right. Actually, not in the entire answer, but just this first term and then these last terms. So if you get this first term, it's 1 point. They're being nice. But all the rest of the terms are 1 point in themselves.